I think there's more to say about async streams. Some things were introduced at WWDC 23 as part of Swift 5.9, and also there's something I want to show you about consuming async streams, in fact, consuming async sequences that you should be aware of. Let's start with an application that is similar to our previous example of async stream. Here, the first time I tap the next button will begin with 1 surrounded by a circle, and each time I tap next, the count will increase by 1. To see what's going on, let's start with main view. As usual, I separate the memory footprint from the computed property that displays the body. Here, the body consists of a VStack with an image on top and a button on the bottom. Our next button will use a controller or a view model as support, and its action is support's next number method. We'll do more in main view, but first let's head over to support to see what's happening on the back end. Support is a class which has to hold on to the count that we're increasing each time we tap the next button. And so the next number method will just take count and increase it by 1. And because I only have the little numbers with circles up to 50, we'll mod this by 51. To return the current count to the main view, we'll use an async stream. Numbers will be an async stream of ints. And you may remember that we think of the continuation like a water slide. Numbers continuation is a property that will hold on to our continuation, and we'll assign the continuation when we construct the async stream. That allows us to use the continuation in next number to place the numbers on the water slide and yield them into the stream. So main view's button action is next number. We call that from main view. Next, we need to adjust main view to listen for the stream of numbers and accept each one as they come down. So far, we have our image and our button action. Let's use .task. So on appear, we begin our task, and on disappear, we cancel our task. You've seen that we subscribe to async sequences with for_await in. Here we for_await the number in support.numbers. And we'll add a state property to store our current value. So as we receive the next number, we'll assign it to current value. To fill out image a little more, image depends on the current value. So every time there's a change in current value, the image will redraw and show us the new circle for that new number. And so again, the result looks like this. Every time we tap next, we see the next number appear. There's a new convenience method in Swift 5.9 that makes this a little cleaner. There's a new makeStream method on async stream. We specify what kind of type we want the stream to be of, and it returns an async stream and the continuation. Our code's a lot cleaner now. That said, async streams have a dark side that we haven't considered. Not exactly a dark side, but there is something you should know about async streams. And it turns out it's true about all async sequences. What I'd like to do is add a second for_await in main view that also listens to support.numbers and displays the same number side by side. So we'll add a second count property to main view. So in addition to current value, we now have filled current value and also initialize it to 0. And we'll add a second task to main view that also subscribes to numbers. So below our existing task, add a new task, create another for_await in that listens for support.numbers. So both for loops are listening to the same async stream, and this time we'll set our filled current value to be our filled number. As for the display, we'll create a second image. This is for filled current value where filled is true, and we'll put them side by side using an H stack. Unfortunately, when we run it, the non-filled is getting all the odd numbers and the filled is getting all the even numbers. What the heck is going on? I have two for_await loops listening to support.numbers. And what you have to remember is for_await is syntactic sugar for a while loop that asks support.numbers make async iterator for the next element. So they're both asking the same iterator for its next element. But that's like having two birds asking the same iterator, I'm hungry, feed me next. And so what happens is first this bird eats, then this bird eats, then this bird eats, then this bird eats. One way we can feed both birds at the same time is for them to listen to different async streams. So each one has its own stream feeding it. So let's create a second async stream in support. Fortunately, this syntax makes it nice and easy. Just make another stream of ints and assign the stream to numbers 2 and the continuation to numbers continuation 2. Next time, we're going to look at this repeated code and find a nice way to simplify this process. But don't forget in next number, we also have to yield the count to numbers continuation 2. And so now we have two streams, numbers and numbers 2, So let's head back to main view to make sure we're listening to both streams. Change our filled number task to listen to numbers 2. And now both birds are happy. They're each being fed by their own stream. Run the app again, and this time we get the desired behavior. Both images get every value of count. Really, that's all I wanted to show you about async streams, but for completeness, let's look at image. Image is a helper method that takes the int to be displayed along with whether or not the circle should be filled and returns a view. We're going to create an image using SF symbols where the base is int.description, we'll append .circle, and then if it's to be filled, we'll append .fill. So that nothing is displayed until we tap next the first time. If the int is 0, we'll use a clear color, otherwise we'll use the primary color, and finally we'll display using a large title. And that's how we get this look. Next time we'll look at that duplicated code and we'll motivate and begin to create a macro. And then the time after that, we'll actually implement the macro.